Start by going to the package manager under Window. Make sure it says Packages Unity Registry and search Input. Click on Input System and install. Once it installs, it'll ask you to restart, so restart the editor. Now that it's done restarting, we can close this out, go down into Assets, right click, Create, go down to Input Actions and click on it, and we'll call this Player Input Actions. On the top right here, make sure Generate C# class is toggled on and select Apply. And what this did is it created a C# class with the same name as the input actions. So it created player input actions.cs. And if we open this up, this is the auto-generated class, which holds all the user input information, but we don't need to look at this because it'll auto-create this every time we modify the player input action. Let's modify it. We can do that by double-clicking on the player input actions, and it'll open up this tab right here. Select the plus near action maps, and this will create a new action map, and we will call this player controls. Now inside player controls, we can add a new action, and we'll call this move. We'll change the action type to value, and the control type to a vector2. You can delete this binding and add a up, down, left, right composite. So now we're going to assign the proper keys to up, down, left, and right, which will be WASD. So select up, then come here to the right, press path button, and then go to keyboard by location of key, and we're going to select W for up. For down, we're going to select S. For left, we're going to select A. And for right, we're going to select D. And we can leave the mode on digital normalized. Save that asset. It'll load a little bit. And if you want to see what this does, if you go open this up again, it auto-generated a bunch of code. As you can see, it just added all of this information, but we don't need to worry about that. Unity does all of that for us. We created our input action. Now we need to activate it because currently it's not running by default. Inside the inspector, right click, create empty, and let's call this object input listener. And we're going to add a component, which will be a new script, and let's call it player input action listener. Edit that script. So the way the input action system works is we need to create an instance of it, then we need to subscribe to all of the input action events, and then we need to enable that input action. So let's start by creating an instance of the input action. So we do private player input actions, input actions. And this is just an instance of the class that is auto-generated by the input actions right here. So in awake, we will create a new instance of that class. Now we're going to subscribe to this move action. So to do that, first we grab the input action, input actions. Then we add the specific action map, which is called player controls. And then we add the specific action, move. Then we're going to grab performed, which is an action. Now we type plus equals and then press tab to auto-generate our code, and we'll rename this to on move, press enter, and I like to rename obj to context. We could delete this throw new system exception, but pretty much whenever the move is performed, meaning whenever ASD or W is pressed, it'll call this method. And what do we want to do? We want to get that 2D vector. We want to store it somewhere that can be referenced later on by other mechanisms. Let's create a public vector 2D player movement input, and we'll make this a property. So get private set, and we're just going to assign the value that's obtained from this context. So to get the value, we do context.read value, and it's going to be reading in a vector2. And we're just going to assign player movement input to that value. And then once this is all done, we need to enable this input action. Enable. Well, obviously we don't want to enable this on the onMove function. This should be done at the end of the awake method. So now when I press WASD, it'll accordingly give me the player input. And as you can see, if I hold two at the same time, like W and D, it gives 0.7 and 0.7 because it's normalizing the vector and giving a magnitude of 1. Now that we are successfully getting the user's input in the form of a 2D vector for the movement, let's apply it to a player to make it move. Create an empty object, rename it player. We're going to add a component, let's call it player. We're also going to add a rigid body 2D, change the gravity scale and the rigid body D2D to 0 so it doesn't fly off our screen. Right click on the player. We're going to add a 2D sprite just so we could see the player. And we could rename this circle to body. Let's make it our favorite color, guys. Just make it the same fucking color as the background so you can't see it. Genius! My soul is the color purple, so I'm going to choose that. Anyway, in the player script, we're going to grab a reference to the rigid body and modify its velocity dependent on the user input. Let's have a private rigid body 2D, and let's call it, rigid body 2D. Perfect. Let's make it a property because in my experience, you're going to be referencing the player rigid body a lot. So we want a private set because the setting is only going to occur inside the player class during the awake function, and we will set rigid body 2D to get component rigid body 2D. And now we need a reference to the player input listener, which has this vector 2 for the player movement input, and we're going to do it the nice and easy way using the singleton approach. So inside player input action listener, we're going to create a public static player input action listener instance. Instance is just the variable name, and let's make it capitalized because why not? And in the awake function, we need to set instance to this. So now inside player, we can easily grab a reference to this player movement input. So let's make our player move. Since we're going to be modifying the rigid body, we're going to do it in the fixed update. Rigid body 2D dot velocity is equal to player input action listener dot instance dot player movement input. So inside the inspector, let's run that. And he moves. Let's give him a player speed. And rather than just having a player speed variable inside the player class, let's properly make a scriptable object player data class because you're going to be adding many more player attributes later on in your game. So let's create a new C# script. Let's call it player data. It inherits from scriptable object, not mono behavior. And we need to create an asset menu so that we can create it inside the editor, and menu name is equal to so/player data. And what this header does is now inside the editor I can create so player data, and we'll just rename this to player data. Let's change it to normal from debug mode. Let's go back into the player data script and create a public float movement speed. In player, we're also going to create a new variable, a new reference to the player data. Public player data, turn that into a property as well. And since we want to be able to see it inside the inspector, we have to do field, serialize field. So now we can grab our player script and we can add the player data. Now we just need to go in the player script and change the velocity, or rather just multiply it by player data dot movement speed. And now he's not moving because the movement speed is 0, but if we change it to 3, he moves. Change it to 5, he moves. Change it to 7, he moves. And if you change it to 9, he actually doesn't move. No, I'm just fucking with you. He moves.